lot of cool data that's stored in SIM cards even today. For example, the last 10 phone numbers dialed from a phone, even if you've deleted your call history. Sometimes sent and received SMSs are still stored. So even, and interestingly enough, even though SIM card cloning was only really popular in the late 90s, it became popular again because that was how iPhones were originally cracked, was to duplicate SIMs, but change a little bit of the information so you could use a different carrier than AT&T. So, but unfortunately, when I looked online for SIM information, all of it was very focused on just either forensics, like really hardcore forensics information, or basically how to hack iPhones. So I wanted to sort of create a more generalized introduction to SIM cards and how to read that data off of SIM cards. And I was going to do that by building a very, very inexpensive SIM card reader and show how to do that in your own home and then run the free and open source software on your own computer.
And from this point forward, you can turn off the house lights if that's okay. If not, we understand too.
So I've got all my tools set up here. I've got my multimeter, my trusty multimeter, which will be used for testing the circuit. The fume sucker, which will be used to get rid of all the fumes from soldering. And my soldering iron. I also have a nice vise for holding the circuit board while I work on it. This is really useful, but you can use a third hand tool as well. So there's three parts of a SIM card reader. There's the power supply section, there's the oscillator section, and then there's the serial port and card interface section. So for the power supply, you'll need a 9-volt battery and a 9-volt battery holder. So we connect the battery up to the circuit board. A 1N4001 protection diode, and a 7805. 7805s come in two varieties, a mini version and big brother version. You can use either one. The power supply should also have an LED that'll indicate when the device is on, so an LED and a 1K resistor. And then to keep the power supply functioning well, a bypass capacitor is necessary. This one is a 100 microfarad capacitor, and this is a small ceramic capacitor. The second part of the circuit that we're going to build is the oscillator section. That's the part that generates the 3.57 megahertz signal that's sent to the SIM card. That lets it run at the correct baud rate. You'll need a 3.57 megahertz crystal, two 20 picofarad capacitors, a 1 mega ohm resistor, a 2K resistor, and a 74HC04 NOT gate. You can also get a socket to put the gate into. Makes it fit nicely. The third part of the circuitry is the serial port and SIM card interface. Now the most important part here is to get a good SIM card holder. This allows you to put the SIM card in and lock it so you can create a good connection with it. And a female DB9 serial port connector. This is what you'll be able to connect to the computer. You also need two Zener diodes, anywhere between 3.6 to 6 volt is perfectly fine, and three 10K resistors. This part is what allows a 10 volt serial port to contact with a 5 volt SIM card reader safely. You also need an NPN transistor, any kind will do. A SIM card has a bunch of contacts on the bottom that allows the SIM card reader to talk to it. Now there's 8 or 9 or 10 contacts here, but only the 6 middle ones are really important. This is what the SIM card looks like on the bottom. Now there's the 6 contacts, and in the middle there's one big contact. And that one big contact is connected to one of the side ones. That's the ground contact. That's used for power and signal ground. Underneath that is the programming pin contact. That's used by the manufacturer to program the SIM card when it comes out of the factory. We won't be using that pin though. We'll be using the serial I/O pin that's right beneath that. That's how the computer talks to the SIM card. On the other side is the clock pin. That's where the reader sends a clock signal to the SIM card chip to tell it what the correct baud rate is. Make sure to be using a 3.57 megahertz clock, which translates to a 9600 baud signal. Above that is the reset pin. That's how the reader says, hey, wake up, we're ready to talk to you. And above that is the 5 volt pin. That's how you send power to the SIM card. card and put the phone to the side. Now, turn over the SIM card reader and slide in the SIM card so that it locks in. Plug in the 9-volt battery. The green LED should be lit. Now, connect up the serial port.
Let's run the software.
Select the serial port that the SIM card reader is connected to. For Windows, it's probably something like COM port 1. First thing we'll do is extract the saved SMSs from the SIM card. Now, some phones don't overwrite old SIMs with zeros or FF, so you can actually extract deleted SMSs and undelete them. Every SMS message has the recipient, the sender, the message, and a timestamp, so you can see when it was received. Next, we'll read the last dial numbers. These are the last 10 numbers that the cell phone tried to call. Next, we'll read the phone book. Now, this is all the contact and phone number information that's stored in the SIM card. Sometimes this is used as a backup, and sometimes it's the primary phone book. Now, it takes a long time to read the phone book because there's 250 entries in this SIM card contact data. Each contact has a name and a phone number. Finally, we're going to look up the SIM information. Now, this is sort of low-level information, the serial number, the last location the phone was used in, PIN statistics, stuff like that. When you're done, you can just disconnect the reader. Finally, if you're interested in the low-level protocol data, you should look through the debug window where you can see what kind of information was sent and received from the SIM card.
Now, let's say you wanted to clone a SIM card. Well, there's no way the SIM card is going to give up the unique identifier and the secret key. But what you can do is perform a known plaintext attack, and that'll hit the SIM card tens of thousands of times using software, which I have running here. And if it works out, you get the key. But most SIMs it doesn't work on any longer, and also it can disable some SIMs. So we're going to run the software. It takes about 6 hours, so let's give it a whirl. All right, so let's see how we made out. Looks like that we were able to crack the SIM card.
Now all we would need to do is copy this information to a writable SIM. This project is done.
All right, so that was the SIM card hacking. Ta-da! Yeah. It's very hard to make electronics exciting. I don't know if we succeeded. Tried. We had some techno music, so what can you do? So the next part is payphone hacking, the thing about payphones is they're all being decommissioned. They're pretty much going away. There's millions of them available, and as we looked around, we saw these payphones, and we wanted to do something cool with it. And we also still have a red box, so we were like, what are we going to do with this red box? So in the next clip. What was that? What? Yeah. So we decided to procure some payphones to do some projects with them, and you can probably talk.
So we're just going to fast forward through the intro for this video. Instead, I'll just sort of explain it very quickly. But most of you are aware there's basically two kinds of payphones out there. There's the standard telco-style payphones, and there's COCOTs, and those are the customer-owned coin-operated telephones. And those actually have real computers inside of them, and when you pick up the phone, it's a fake dial tone. And all the calculation about how much money to put in, and whether it's time to hang up or if it's a collect call, all that is done inside the payphone. But telco payphones, which have had pretty much the same design for like 30 or 40 years now, because they didn't have microcontrollers, microprocessors when they were first invented, all of the thinking and the hard work of what money is owed and whether coins have been put in have been done on the switch side, right, at the central office. So what that means is that these payphones are really dumb. There's actually no electronics in them, very, very little electronics in them, and almost all the control is done using really strange voltages that occur on the switch side. So although we'll show how you can modify a payphone for home use, all the cool stuff that payphones do you can't get out of a home phone line. You just can't get it out of the voltages that come from a home phone line because it's not a special phone line switch. But we got this payphone, and we decided, this stuff is so cool. We opened it up, and I'd never actually seen the inside of a payphone. And so I thought, well, I used to hack payphones from the outside, but I thought it'd be cool to hack them from the inside instead. So we kind of split up the project into 3 parts, or 3 or 4 parts, and we show some really cool stuff you can do with payphones, especially the telco style. So let's just play the video, and hopefully it'll be self-explanatory. And you can play with this payphone. We'll have it at the vendor table downstairs. It's not plugged in here, but we'll have a VoIP box so you can hack it.
It's going to look similar. What you want to look for is Bell logos, Bell names, anything that says, the local telephone company on it. Every brand of payphone has its own T key that's used to open it up. Put it in the side and turn. Remove the handset, then pull the front off. Be careful because inside there's a plug from both halves. Connecting up a payphone for home use is pretty easy. First, you'll need a telephone wire that has telephone spade lugs on one end and standard screwdriver. Feed the telephone spade lugs through the back of the phone. Then connect the red wire, which is the ring, to this terminal block marked R. Second, connect the green spade lug, which is the tip, to the terminal block marked T. Finally, take the black and yellow wire, which are not going to be used, and tie them to the ground connector. The coin counting circuitry has to be jumpered so that the phone doesn't expect a coin to be inserted before it can make a call. Now, that's actually already been done here by jumpering pin 5 and pin 8 on this plug. Otherwise, you can just solder a piece of wire in to connect the two. Now simply plug the payphone into your home phone line, or in this case, a VoIP box. Now's a good time to test the wiring. It's pretty easy. Just call the phone from another line. There are many distinct parts to a payphone. On the left, there's the coin sorting mechanism, which detects valid currency. And then below that is the coin hopper. That's where coins are stored while the payphone makes a phone call. And then this is the coin relay. This controls whether coins in the hopper go into the coin box or into the return chute. On the right side, there's the bell, the phone line terminal block, the coin tone oscillator, and the connectors and jumpers for the 2 halves of the payphone. Here's where the totalizer would live. Now, unfortunately, the totalizer was ripped out of this payphone before we procured it. On the other half of the payphone, there's the handset switch hook detector, the tone pad, which is on the back, and the DTMF encoder and terminal block. To remove the coin assembly, first flip this latch, then reach in and push on the wire ring, and this part just comes out. To open up the coin assembly, just flip it open, and then these magnets also flip open. When a coin is inserted into the payphone, it travels down this chute. Now, in this case, a quarter will pass by the quarter separator. Only if it's the correct size and weight will it rotate the separator and cause it to pass past this magnet. This magnet sets up an eddy